Hey everybody, this is Mitch from BoardCo. Today we're going to be going through and showing you a comparison of some different surf systems that are out there on the water and the difference between the surf system that Centurion and Supreme boats run versus other boats that are out there. We're actually going to be comparing it today against an Axis A22 that I've got right here. One of the big misconceptions that people have when talking about surf systems is they think a surf system is just purely the device that sits at the back of the boat that controls the flow of water from one side to the other. That is part of the surf systems, but any surf system on a boat is going to interact with some of the other different things that are on a boat. In particularly, the ballast that is in the boat, how much and where it's placed, and then in addition to that, the hull design on the boats. We're going to go through and show you how each of these is different and how the different surf systems will perform differently out on the water in a few key areas. We want to show you the differences as far as the efficiency of the surf system. In other words, how much fuel it consumes, how loud it is, different variables like that. The second thing is the drivability of the different surf systems, how those surf systems impact the way that the boat handles and drives through the water, in addition to the visibility for the driver while using those surf systems. The third thing is what they can do as far as manipulating, changing the flow of water to create a wake surf wave and how they differ from one to the other. These are some things that we're going to point out as far as the differences between these two boats. So the two boats I have here is a Centurion VI22 and an Axis A22. One thing that's important to point out here is the Axis A22 that we have here is a 2018 model. Now, there's a specific reason we have a 2018 model, and that is because at this time, Axis was actually utilizing motors from PCM, the engine supplier that is used in Centurion and Supreme boats. Now, this boat and this boat both have the exact same engine in the boat, as well as the exact same propeller configuration. We'll talk a little bit more about that in a second, but it's something that allows us to universally show aspects such as the fuel efficiency, the engine noise level, and different things like that when comparing these two boats, so that we can isolate those areas, those variables, directly down to the surf systems themselves and not have to go into any factors like the propeller or anything else like that. So we're going to put these two boats in the water, let you see them side by side, and show you how the different systems compare, as well as why you're going to see the results that you will. All right, starting off and showing the comparison between the different surf systems, we are first out here in the Axis A22. Now, the first thing that we're going to talk about is the efficiency of the surf systems themselves. And one of the ways that we can show that really effectively is by hooking a Diacom system up through a laptop right here, and hooking up a Diacom cable and running it to the motor and being able to show you the output of everything that's going on in the engine, how hard the engine's running, how many RPMs we're running at, the fuel consumption rate while it's at surf speed, things of that nature. Now, we've done this before with a few different boats, where we compared the fuel consumption on Centurion boats to other boats that are out there. And the results were quite honestly a little bit shocking. They were shocking even to us when we were first hooking them up and seeing how much more fuel efficient the Centurion boats were because of the combination of the hull design, the surf system, and a few other different factors. So what we wanted to do is we wanted to show you that we weren't hiding anything or doing anything funny with the results that we get as far as fuel consumption on this boat. So we're out here in the Axis A22. Currently we have straight factory ballast setup. I hesitate to use the word factory ballast a little bit because this boat does have the plug-and-play ballast bags here in the rear lockers, and those are not installed by the Malibu factory. They plumb the boats for the ballast systems, but they don't actually install the ballast bags into the boat. So these were added by the dealership. So those are not necessarily factory, but most of the time when people are talking about factory ballast, they're including these plug-and-play bags in. They don't install those from the factory just because it allows them to have a higher capacity rating on the boats when those are not installed, which is how they rate the boats. And then the dealers install them after the fact, but they can still post the same amount of ballast capacity on the inside of the boat, even though the boat may doesn't actually pack that many people or that much weight. But I want to give you an idea and show you. So I'm gonna go through and lift up these and show you. So we don't have any extra weight or anything funny at all in this. So I've got the factory plug and play bags. You lift them up, you see there's no additional lead weight or any additional ballast weights or anything like that anywhere. It's just the hard tank subfloor ballast and the factory ballast. Moving here into the inside, we've got some shoes in that, but we don't have any extra weight or anything like that anywhere in any of the boats. Same thing, just a couple little Coast Guard pieces of equipment, but nothing as far as weight goes underneath any of the sides here. Basically, we're running just a completely empty boat, except for just a little bit of gear that we brought in for us here. So we've got some life jackets here, then we've got the cover for the boat, and the batteries are sitting right here. That's pretty much about it. And we don't have any additional weight up in the bow, even though if we did, it would actually end up giving us, it would actually end up helping with the fuel consumption on this boat. So we definitely didn't add any additional weight up there. And then there's 4 people up here in the boat. So myself, Troy's in the driver's seat, Tom's right up there at the front. He's gonna be moving back here when we're going and doing the testing, and then Haley's behind the camera here. So there's no additional weight. Also wanted to show you the motor that we're running in this boat is a Monsoon 409. This motor was actually at the time manufactured by PCM. So the same engine manufacturer that builds motors for Centurion. This is the essentially the Crusader 409 motor. It's a 6-liter, 410 horsepower motor that is a GM Marine engine. So this is the exact same motor and exact same propeller setup that we have on the Centurion boat that we're going to be showing you here in just a second. So when you're comparing between the two, the only factors that are the differences between these two boats are the devices at the back of the boat that control the flow of water, the hull design on the boat, and the ballast placement, so where the ballast is located in the boat. We'll talk a little bit about how each of those factors makes a difference, but we'll go through and fill up the ballast, show you that getting full so you can see we're filling all of the factory ballast in the boat, and then go through and show you exactly what we get on this one as far as efficiency goes. All right, we've got the ballast all full. You can see here we've got the plug and play bags totally full here in the back. The bow ballast is full. I can't really show you that because you saw a video of it, the ballast spitting out the sides, but the center tank and the bow tank are full. I can't show it to you because there's no monitoring system on this boat or anything like that. They can show you the ballast levels, so you just fill them until the water spits out the side. But there's a couple things that we want to point out. So as I mentioned, same motor, same propeller. Couple other things to point out. The boats that we're testing, the Axis A22 and the Centurion VI22, are roughly about the same size. They're both 22 footers. They pack really similar amounts of ballast if you factor the wedge as the full 1,500 pounds that they market it as. If you include that as full 1,500 pounds, which we're just going to assume that's 1,500 pounds of downforce at surf speed. They don't really talk about what it is at different speeds, but we'll just go with that assumption, I guess. And with all the ballast full, we're running really similar levels of ballast between the two boats. The only difference is the VI22, the Centurion, is about 800 pounds heavier as far as a boat goes, but we're not factoring that into anything. We're just going to take the numbers as they sit, with ballast being roughly equal between the two. So we've got it all full. We're going to be set. We're going to hook up the Diacom and start the boat up and start driving and show you what we end up getting. All right, we've got our Diacom hooked up and we're ready to rock and roll. You see on the Diacom screen, you can see all of the data and the information that the boat is spitting out. Now, we've taken and blown up the fuel consumption right here because that's the number that you're going to be wanting to take a look at the most, obviously. But you can see all the data. It shows you RPMs, it shows you the speed we're running at, etc. Now, we've got all the ballast full. We've got 4 of us here in the boat. We're distributed equally throughout the boat here. We've also got the wedge to start at a setting of 1. So we're gonna just run it and show you what the fuel consumption is looking like when the wedge is just barely engaged at all. So this is quite a bit less ballast than we're running in the Centurion with the wedge set at a 1, but you can get an idea of what's going on with the efficiencies of the surf system. So let's take off and show you what we get.
so as you can see, we're throttling up. You heard the cruise control beep. We're now running at 11 miles an hour. And you can see with the wedge at a setting of 1, we're burning about 12.5 gallons per hour. This is while we're running and surfing. We're about 13. So we're going to go from a setting of 1 with a wave that's a little bit smaller, and we're going to take it and crank it up to a setting of 5. Now, on the axis, it has the ability to go from a setting from 1 all the way up to a setting of 6. We're not taking it all the way to 6 because a lot of people don't run it that high. But also, the boat won't quite get to speed. It caps out at about 10.5 miles an hour. So now we were running at a setting of 5. We drop down and we're running at about between 14.5 and 14.8 gallons an hour. You hear the cruise control beeping quite a bit in the background. It's keep trying to hold speed, but it's having a hard time holding at this speed with the wedge at a setting of 5 with 4 of us in the boat. So we can draw back down, as you can see. So you can see we're running between, depending on what wedge setting we were at, we're running at between a 12 and a 14.5 and about 15 gallons per hour was where we were sitting. The lowest we were running with the wedge barely engaged was about a 12. On the upper end, it was 15 gallons per hour. Now, there's a few factors that come into that. Most of the weight in the boat is situated behind the driver's seat, but about 80% of the total downforce between the wedge and all the ballast is sitting from here backwards. And so the bow is sitting a little bit high in the water, or high up in the air, which is why it was really difficult for us to be able to maintain our surf speed. So we were gunning for 11. It was kind of feathering and hitting 11 with the wedge up at a setting of 5. It's why we didn't go to a 6. But you can see that that's where it's at. You can obviously run at a 3 or a 4, and you're going to have a little bit less fuel consumption. But 12.5 is about the bottom line that you'll hit with a setting at 1. So now you understand what the fuel consumption is like on the axis. Let's jump over to the Centurion VI-22, and we can see how it compares with the different surf settings and surf systems that are available on the Centurion. All right, we're now out here in the Centurion VI-22. We're getting set up to show you the efficiency on this boat. But before we do, I wanted to do the same kind of thing, show you what we've got as far as ballast, and that we're not hiding anything or having any tricks or anything like that. So starting back here in the back lockers, we've got the plug-and-play ballast back here, as well as the subfloor ram fill tanks. There's nothing in addition, but these are all factory plumbed in. They are not dealer installed. That's all factory ballast. So it does factor into the weight capacity and ratings on the boat. Moving along, we've also got nothing really underneath the side seats. We've got a cooler in there right there. Over here on this side seat, lifted up on the hinges, is just clear open storage. Moving up to the bow of the boat, you see here, we've got essentially nothing in the bow. So it's just clear open storage right there on this side. Same thing over here on this side of the boat. Clear open storage here. So we don't have any additional weight up in the bow. In fact, there's actually an optional bow plug and play bag that we don't even have installed in this boat. So the bow plug and play is an option that really we only put on boats if you're going to do a lot of really high-end wakeboarding with a ton of ballast in the boat. But because the ballast configuration in these VIs sits so much more centered or forward than it does in the axis we were just in, we don't need to have a whole bunch of weight up in the nose to keep the bow down and to make the boat run level through the water. And the main reason for that is the big, huge round fill ballast tanks that start at the very back of the boat, and they go all the way forward to about right here, like windshield level here on the boat. So the boat is a lot more balanced. We also do have one bow tank that sits under the floor right here, and that's going to be the only thing that we fill that's in the bow. So it's all factory. There's no additional weight or anything, but we're going to fill the ballast up and show you the ballast once it's all full, and then take it and show you what kind of efficiency we get out of this one. All right, we've got all of our ballast full and we are set to go. I'll show you really quick. We've got all of our plug and play ballast here in the back completely full. We also have all the ram fill full as well as the front, as well as the center tank. You see here in the in the VI-22 that we're in, we actually have ballast monitoring. So you can see all of the ballast settings that we're at. You see we're at 100% full on everything. We're not leaning the boat to the side or doing anything different. We've just got the 4 of us here in the boat, all of the standard settings, etc. Currently right now we've got the quick surf plate set at a rating of 70, right down the middle of where you expect. We also have the center plate set at about 70 as well. So that can go anywhere typically between 20 and 90, just kind of depending on the shape of the wave that you want. But 50 to 70 is pretty standard right in the middle where most people like to surf. So that's where we're going to start at. So we've got all these things dialed. You see right here, we've got my Diacom hooked up. You've got your fuel consumption rate right here, as well as all the other information such as our RPMs, our speed, everything like that. So we're gonna go 11 miles an hour just like we did in the Axis and show you what we get. So, all right, we're ready to go. All right, so you see it's taking us up. We're running about 9.5 gallons per hour while we're underway. So it's feathering between about 9.25 up to 10, just kind of depending on where we're sitting. You can also see we have our RPM rate right over here, and we are currently running at 3150 to 3200 RPMs. When you compare that to what we were running in the Axis, even though we had less weight and less weight in the boat as far as ballast and a lighter overall boat, we're running up at 3,800 RPMs. A lot of that is just due to the angle that the boat moves through the water, but what happens is because this boat, the VI-22, is moving at a flatter angle to the water, not only are we getting lower RPMs and less fuel consumption, we're also getting a wave that's a little bit longer back behind the boat. So this is what they're running at a 70. Troy, take it down to about a 30 on the center plate. And you see we can go through and steepen this up a little bit. And when we really take it all the way to the steepest setting that we'd want to run right here, it gets quite a bit steeper, starts to barrel over, and we take it up to a fuel burn rate of about 10.5 is what we're getting. So what we end up with when we go over here is we end up with a total fuel burn rate of up to about 11 is the max we ever hit on the VI-22 with the wave stacked as steep as we can get it. Where on the Axis, 12.5 is the starting rate before we engage the wedge. So you end up with a overall fuel consumption that is about 40% less on the VI-22, and that is once again with the same motor and the same propeller on both boats. So the only variable is the surf systems that we are running. So now that we've done that, let's go jump over to the other boat, and we're going to go and talk about the drivability and the visibility of each boat.
The next thing we're going to show is the drivability of the boats when the surf systems are engaged. When you talk about the difference between a brake style surf system, or one that has a brake or a gate or something that goes out the sides of the boat, versus a tab style system where it deploys down, there's a little bit of a difference about how it affects your steering. So what we're going to do is we've got the boat set up here with surf over here, surf left, so surf over here on the port side of the boat. And we're just going to drive along, and then I'm just going to let go of the steering wheel and show you what ends up happening, to show you the amount of counter steering and pressure that you have to hold on to the steering wheel in order to keep the boat driving straight. So we're going to take off and just go here. So right now I'm holding the steering wheel pretty hard over to the one side. So you see we're going 11 miles an hour. We've got the Surfgate go left, and we have the wedge at a setting of 4. When I let go of the steering wheel, you see it will drift this way, and it will end up drifting a lot harder and pull us really hard to one side if I just leave it and let it go. So I have to overcorrect to go back here and to end up correcting it back over straight. So there's a lot of pressure on the steering wheel, and the reason for that is it's to overcompensate for the strain that is being put on one side of the boat and on the engine by having that brake kick out on one side. So let's jump over and see the difference between this style system versus a tab style system like the Quick Surf that we have on the Centurion and how it differs. All right, we're back here in the VI-22, and we're going to show you how this boat handles as far as steering while the surf system is engaged. So you see we've got our quick surf active. It's set at 70%, so we have the ability to control and manipulate it on this boat. But 70 is a pretty standard setting most people run. We also have all of our ballast full that you can see from the dash screen right here. Now what I'm going to do is I'm going to take off and I'm going to have the boat running totally straight and let go of the steering wheel just like we did on the Axis. So you see we're driving straight. We've got our surf wave form back there. What I'm going to do is I'm going to go through and let go. And you see, I don't have to do anything. It's not twisting or turning. I don't have to compensate. In fact, I'll show you this. Beyond just not having to hold the steering wheel with the full handle grip or two hands, I can turn the entire steering wheel on this boat really easy from side to side with one finger. So that just shows you the balance and precision of having a tab-style surf system with a V-hull as compared to a flat surf system with a gate that goes out the side that really is going to be fighting and pulling against your steering. That fighting and pulling against your steering is also part of why we saw the increased fuel consumption on the other boat as well, because you're having to fight against the steering and the motor's having to fight against that as well. So hope that is helpful. We're going to jump back over the Axis. We're going to look at visibility, or how well we can see and how well a driver can see and navigate while they're driving the boat. All right, next we're going to demonstrate and show you the visibility differences that exist when you're talking about the differences between the surf systems. This is a lot dealing with weight distribution as far as where the ballast is located, as well as the difference between a system such as the Stinger plate and a wedge design. The Surfgate versus the quick surf system on the Centurions, though the side plates, they have an impact on this as well. But what we're going to do is we're going to show you the amount of bow rise that you get on each boat. Now, one of the ways we thought would be really nice to demonstrate that you can compare is with this beautiful looking GoPro setup that I have on my head here. So you can see the exact visibility I have. It's actually a couple inches above my eyesight line, which is probably nice because I'm not a super tall guy. I'm 5'8". This will take it up to where it's somebody who's about 6 feet, right in there. And you can see what we've got. Now, here on my settings, I've got the wedge at a setting of 4. We've got 4 people in the boat here, and we've got all the ballast full. So the ballast in the bow is full as well as the ballast in the rear. And we're going to take off and just show you what I can see and the kind of visibility you have. I am sitting up here on the bolster on the seat, so I'd have less visibility if I drop that down. But we're going to take off and just see where we're at surf speed when we hit 11 miles an hour. So we've got surf left engaged, so we're kicking over here to the left side. And you can see the visibility that I've got. When I sit back here in the chair, at this point in time, I really can't see anything over the bow. Even if I sit up really high, I still can't, looking to try and see, I still can't see over the front of the boat. Now, if I press surf right, just to show you the difference, so I kick over so surf right, so the steering flips, I can see just the same. In fact, I can see even less going out here on the port side of the boat. Now, if I stand up, that's when I can get some visibility. So you'll see I stand up, and now I can actually see over the bow of the boat. But until that time, I really didn't have any visibility when I'm sitting in the bolster seat. So dropping back down, you can see where I'm at as far as visibility there. So now the bow drops all the way down, and now I can obviously see over the very front of the boat. So that's what we experience here in the Axis that's got the combination of a wedge, Surfgate system, and ballast distribution where the vast majority of the weight is at the very back of the boat. Roughly a little over 80% of the total displacement is coming from behind the very back seat. We'll jump over to the Centurion and show you what the differences are there when we jump over to the different systems. All right, we're now over here in the VI-22. I've got my awesome headgear back on, ready to film the GoPro so you can see my level of visibility looking out the front of the VI-22. I'm sitting here, I've got the bolster flipped up just like we did in the Axis. And right now, currently, I've got the settings on this boat a little bit unique. I have the center Stinger plate setting that you can see right here in the middle. I'll pull up this screen so you can see it easier, at 0. This is not necessarily the setting you're going to run most of the time while you're surfing, because it's going to bring the bow higher than we normally would like. But I want to show you how much visibility you have in this boat when the bow is at the highest point that you can have it while you are surfing. So literally, we can't make the bow go any higher without adding more weight and people here in the back of the boat. So we've got all the ballast full, same 4 people that we had when we were running the Axis. And so I'm gonna drive and you're gonna be able to see what we've got as far as visibility goes. So we're driving along and you can see I'm sitting here on the bolster and I have plenty of visibility going out the front. So I have no problem seeing over the front of the boat. I can see all around me. I can see across a full 360 degrees, all the boats all around me. This is going to do a few things. Not only does it end up giving me great visibility and it's safer, it also means that I have the ability to stretch out a longer surf wave because the bow is further down in the water and the entire hull is displacing water, not just the very back end. If I take this and go to a place that we normally sit out when we're surfing, as a setting of about 50 or so, you see it brought my bow down even further. I can see plenty over the front to the point that even if I flip the bolster down, I still have full visibility going out the front. And I'm not a very tall guy, only 5'8". So I'm looking over the front, have full visibility even when the bolster is down, which is a pretty far cry away from what we experienced in the other boat, where I not only couldn't see with the bolster up, I had to actually stand up to be able to see over the front. Now, wanted to talk a little bit about why we're experiencing this. It is having to do with the fact that the ballast distribution that we have in the VI is very different. The ballast is more centered in this boat instead of the vast majority of it being back behind the back seat of the boat. That's going to allow us to have the entire hull of the boat down in the water, which is really what you want primarily when you're surfing. It's going to give you greater visibility, it's going to give you a more powerful surf wave, but it's also just going to be a better overall distribution for fuel efficiency, for having a longer surfable pocket, and just really everything that you want while you're surfing. It requires engineering the boat differently and prioritizing surfing on the engineering of the boat, but that is what the guys at Centurion decided to focus on. So hopefully that's helpful to be able to check and show this to you. We're going to jump back in the other boat and we're going to go through and show you what we're talking about when we're looking at the different capabilities of each system to manipulate and dial in a surf wave and change the size and the shape of it. All right, you saw what we ended up doing with the camera mounted here on my head and the impact on driver visibility of the different surf systems. We now wanted to give you a more concrete data point for the engineers out there in the group that really just want to know the raw data. We wanted to give you some data points to give you some reference on how much bow rise is going on between each boat. So we're here in the Axis and I have an app pulled up on my phone that is sitting here on the floor of the boat. And what it's doing is it's measuring the degree of angle, basically like a level, as it sits right there across from side to side and front to back. So right now we're at a 2-degree angle essentially from the back of the boat to the front, which considering the ballast that we have, that's right about right and what I would expect. So we're gonna take off and start going surf speed and you'll see what the angle that we're sitting at. Currently I've got the wedge at a setting of 4, full ballast and 4 people in the boat just like before. So as we take off, you'll see that we go from an angle of 2, the bow shifts up, and as we get up to 11 miles an hour, you see we get up to a setting of about 15 or 16 degrees is where it settles at. It goes a little higher and then it settles back down to 15. And so the boat is moving at a 15-degree angle through the water. So 15 degrees between the transom of the boat and the bow of the boat. All right, now that we've checked that and saw the 15-degree angle the Axis is moving at, let's jump over to the Centurion and see what angle that boat moves at as it's going through the water. We're sitting at about a 1-degree angle. We were going through a few waves are hitting us, so it's bouncing back and forth. We're gonna drive and you see, if you remember, we had a 15-degree angle as the boat was moving across the water in the Axis. When we're talking about in the Centurion, we're running an angle of about 7. That means that the bow, or the angle going from the back of the boat to the front, is literally half what we were experiencing in the Axis, which is why we have so much less bow rise and so much more visibility that is available here in the Centurion. So 7 degrees of angle as compared to 15 degrees worth of angle.
You'll see right here, we'll have a pop-up on the video. We're actually going to give you a measurement on how much higher the bow is going to sit in the water when you're at the different angles. To give you an actual measurement, we're going to have to do some math on that. But we'll stick that in there so you can see how high the bow will sit out of the water on an axis versus how high the bow will sit out of the water on the Centurion with 15 degrees of angle versus 7 degrees of angle. Hope that's helpful. We're going to jump back in the axis and show you some of the ability to manipulate our surf waves. All right, now that we've been able to show you the effects on the driver with the drivability and visibility on the boats, as well as the effect of the efficiency on the surf systems, we wanted to show you the differences as far as actually creating a surf wave that they have. Now, you're going to have a lot of similarities. You can go from surfing on one side of the boat to changing over and surfing on the other side of the boat. The method by which the boats do that is a little bit different. In the axis that we're sitting in here, we have a flat hull shape that's going to have a gate that shifts the flow of water from one side to the other, and it's going to crab and yaw the boat from side to side. That's part of why we saw a decrease in efficiency, is because we're actually changing the angle that the boat moves through the water pretty dramatically as we're going. Now, there are some advantages to that system. If we're going to be jumping from surfing on one side to surfing on the other side of the boat, this system can do it a little bit faster. So if you're doing wave transfers, in other words, surfing on the port side to jumping over and surfing on the starboard side, that transfer is about 1 second faster, or about a half a second to a second faster on a boat with a flat hull and a Surfgate system versus a boat with a V-style hull and a tap-style system. So there are some advantages there. What we're going to do now is we're going to show you the adjustability of the different systems. Now, the Surfgate that is here on the axis is pretty simple. It's just on or off. So we can go from surfing on the left to surfing on the right, but there's not really any adjustability to the Surfgate system itself. Where there is the adjustability and the ability to change your surf wave is with the wedge. And so what we're going to do is we're going to go from having the wedge in kind of a neutral or a middle setting, a setting of about 2, show you what happens when we take it up to a higher setting and back down to a lower setting. So we're going to take off here and show you what we end up getting. We've got the wedge at a setting of 2. And as you see, we're kicking a wave over here on this side. The wave's got some good size to it. We've got 4 people in the boat, 2 of us here on the starboard side, 2 of us on the port side, and the ballast is equally distributed between the 2. So we're at a setting of 2. Let's take it up to a setting of 5 and show you what it is with with maximum displacement. So as we do that, you see the engine revs up a little bit more, and the wave just gets a bit taller. As it gets taller, it does get a little bit steeper, but it primarily just increases the size of the wave. It also reduces some of the cleanliness. Now let's take it from a 5 and we're going to go down to a setting of 1. So as we shift it down and go down in the settings, you're going to hear the motor wind down a little bit. It's not going to be engaged as much. The wave is going to shrink a little bit in size. It's not going to be quite as tall, and it's not going to be quite as steep. But really, the shape of the wave doesn't change a whole lot. It really is just changing the size. And that's what you end up getting as far as the difference with adjustability. So we'll pull back down into neutral so you can hear me a little bit better. And you can see the differences that we ended up having as far as wave adjustability was you have the ability to change and make the wave a little bit more mellow or a little bit more steep, but really the wedge is changing the size of the wave. And it does a good job at it. It's really similar to adding additional ballast into the boat. So our wave shape remained relatively similar across the board. Let's jump over into the Centurion and see how that differs and what the differences are as far as creating a surf wave and the different shapes and sizes and that we can create on that boat. All right, we're back over here in the VI-22 and going to give you an idea of what to expect as far as the wave creation capabilities. So in the VI, we have 2 different systems that we can utilize to shape and dial in a surf wave. We have our center stinger plate that's in the middle that controls the angle of the boat up and down. Basically, it lifts the bow up or brings the bow down further into the water. That's somewhat similar to what we get as far as the wedge, but it doesn't have quite the same control. It doesn't necessarily make the wave bigger
or smaller, it just changes and rounds out the shape. In addition to that, we have our quick surf plates on the sides that are not just a simple on and off like we experienced with the Axis, but rather we can engage them anywhere from 0 to 100. There's actually 20 different settings you can put those plates in, and that's independent of the 100 different settings that are available on the center stinger plate. The ability to control both of those aspects really lets us do some very unique things as far as shaping a wave. We're going to show you what those are. So we're going to start out, we have the center plate at about a 30, which is a fairly steep setting. So we'll show you what a wave is with a steeper setting, and then we're going to take it up from there and show you the range of what we get. So we're taking off and showing. So as I mentioned, we got the wave set, the center stinger plate at a 30. We also have the quick surf plate at a 70. So you see this is a steeper wave. It's got a little bit of wash on the lip of the wave, but it barrels over and it's got a steeper profile shape to it. This is really, we have some other things we can control, obviously, like speed and ballast, but this gives you a good idea of what the wave is going to look like with just everything full. Next, we're going to move to a setting of 50 on the center stinger plate and show you what that does as far as controlling the shape of the wave. So you see here, it kind of rounded out the lip. So the wave remains similar size, but we have a rounded lip face. This is going to be better for spinning 360s on the top, or just having a smoother area to play around with if you're not a really big rider or riding a skim style board. Next, we're going to take it up to a setting of about 80 or 90. And this is going to really round out the face of the wave and going to make a more mellow wave for smaller riders when they get out there on the boat. So that one right there is a great setting. It smooths out the face. This is a great wave for smaller riders, guys riding on skim style boards, really anyone that wants just a smooth, open face that isn't too aggressive. It also stretches our wave out, so we got lots of wavelength there. It's great for controlling lots of things. We did all of these different settings without changing the quick surf settings. Now let me show you a wave setting that you can't get on any other boat. So we're going to adjust the quick surf and take it from a setting of 70 up to a setting of about 95. So by doing this, we're going to be able to control and really smash down and round out the face of the wave so that you have a wave that is much easier for smaller riders. So you see we got this shape right here. You see it's really rounded and flat at the front, but it still has a little bit of hook at the back of the wave to keep someone from falling out the back. But the front of it is just really smooth and gradual. I have younger kids. I have a 5-year-old and a 7-year-old. And when my 7-year-old likes to get out on the wave, he's just learning how to surf by himself behind the boat. And he can get out there on this wave, and I can dial a wave in for him without having to empty any ballast out of the boat while we're doing it. It's great because he can get back on that wave. He's not going to slip and fall off the face of it. He gets to hang out. He's got plenty of power to be able to stay on the wave, but he's not sliding or flopping around. And that's just simply because the wave itself is so gradual and mellow for him. So that's one thing you can do on a shape on a Centurion. We can also make it hook further at the back with that gradual lip on the front. We can make it so the entire wave is steeper. We can do really anything you want as far as customizing a wave shape to you. It can be easy as just pressing surf left or surf right, or you can make it as complex as you want for dialing in the ultimate surf wave for everybody on your boat. All right, we just pulled off the water with the Centurion VI-22 and the Axis A-22, and just want to do a quick recap of all the stuff that we covered. We took a look at the surf systems that the boat has, or boats have. And when I mean surf systems, I'm talking about the devices that are at the back of the boat that control the flow of water. I'm also talking about the hull design of the boats and how they are going to interact with those systems at the back of the boat. And finally, the ballast in the boat and the ballast locations. We saw how those different things impact the efficiency of the boat, the fuel consumption that the boats have, and how much strain is put on the engine and how much noise is created while we're driving. We also took a look at the experience for the driver, how those different things will impact driver visibility as well as the handling and steering of the boat. Lastly, we took a look at the different ways that they can create a surf wave and the advantages and disadvantages to each system. Now, there's a few things I wanted to point out. First off, as I mentioned previously, the Axis that we are comparing this VI22 against is a 2018 Axis A22. There's a couple reasons why we really wanted to get this boat. One was because we're talking about how it has the exact same engine and exact same propeller specs as the VI22 that's behind me. This was important when we're talking about fuel consumption because really it comes down to just those surf systems that I mentioned as to the difference between the two and the fuel consumption that they each create. The second reason why we wanted to have that Axis A22 is because it demonstrates the differences between the two boats across all three of those surf system variables. The actual systems themselves between the gates versus the tab style system, a wedge style system that the Axis had versus the stinger plate that was on the Centurion. We also could take a look at the hull design, what we have with a flat style hull versus a V style hull, and how those systems will interact and what we end up with because of them. Lastly, we took a look at the ballast system between the two boats and how the Axis has a ballast system that is much more rear centered versus the central settings on a Centurion VI. If you're looking at a Centurion boat compared to other boats, they may have other areas that they are similar to a Centurion that are not the case with the Axis. It's kind of the polar opposite on all three of the surf systems to the VI that we have. The last thing that we want to talk about when it comes to the Axis boat versus a VI is a lot of people may look at them and go, well, yeah, that's great. The Centurion's a premium model boat, where the Axis is a lower tier brand. And of course the Centurion is going to be nicer and it's going to be better. Well, the Centurion VI that we took is one of the boats in the new VI series from Centurion. One of the notable points about it is that this boat right here behind me, the VI22, comes in at a price tag that's only about $5,000 to $7,000 more than what you can experience with an Axis A22. Same type of thing with an Axis A24 versus a VI24. It's only just a few $1,000s difference. So one of the things that you can ask yourself when you're looking between the different boats is that few $1,000s extra worth all of the things that you get? Not just the surf systems that we talked about today, but also all of the other different features such as the nicer tower design, the nicer interior, the nicer vinyl, the nicer build quality, all of those different things. These are important factors when you're looking at a boat, and you can pay attention now to those different surf systems and how they're going to complement the way that you are going to use your boat out on the water. We hope this has been really helpful. It's been fun for us to be able to check and see the differences and notice how Centurion does things a little bit differently than other boat manufacturers. If you want to experience this for yourself, let us know. We'd be more than happy to take you out on the water and let you get a first-hand experience with what the Centurion boats have to offer. Let you get behind them and surf on them, see the best surf wave in the world like we claim, and we actually get you behind the steering wheel of the driver's seat and let you actually experience and use the boats firsthand for yourself. The difference is not small, it is significant compared to other boats. We hope this information helps. Check out more information that we have in videos and blog content and that on our website, BoardCoBoats.com. Also, subscribe to us on YouTube, and we'll be happy to deliver more information to you directly. We appreciate it a ton. Thanks for spending some time with us, and we'll talk to you soon.